Hi everyone, this is Avi Soltera. Today we're going to be going through Calculus for Engineers, Antiderivatives in Motion, just part 1. And we're going to put together position, velocity, and acceleration. We're going to connect them up using calculus. So just some reminders as we get started. One, you are going to want to have this worksheet printed out so you can write along with it as we go. Other reminders, just things that we've talked about before, the derivative of position with respect to time. That gets you velocity. The derivative of velocity with respect to time, that gets you the acceleration. But we can go in reverse using anti-differentiation from acceleration back up to velocity plus a constant, and from velocity up to position plus a constant. And that's what the antiderivative can do for us. Alright, so let's move on to looking at a concrete problem here. Suppose I am driving along in a car at 30 meters per second. That's about 65 miles an hour. And then up ahead, I see something, and I slam on the brakes. And the brakes give me a constant deceleration of 10 meters per second squared. Now my question for you guys that we're going to solve together is how far and how long am I going to travel before I come to a stop? Right, so we're going to work on that together now. So first we're going to start by understanding the problem and setting it up. We're going to let a of t be our acceleration, v of t be the velocity, p of t be the distance from the starting point. We've got to pick a frame of reference. Now with those in mind, I want your help filling these in. Just like I always say, I'm getting old, I forget things, so I need your help. So the acceleration was a constant negative 10, so that means a of t is going to be equal to minus 10. Not really a big surprise. Now the initial velocity, that's the velocity at time 0, is 30. So v of 0 is going to be equal to 30. Alright, now also at time 0 I'm at the start position, so p of 0 is going to be 0. Now there's one other piece of information we have. We know there's some time when the car is stopped. We're going to call that time TF. We don't know what it is yet as a number, but we still know things about it. The car is going to be stopped at TF, so V of TF is going to have to be equal to 0. Good. What is it that we're trying to find? We want to find two things. One, we want to find TF, or how long it takes till the car is stopped, and then I led into the next one, which is we want to find how far we've gone. So P is our distance, so P of TF, that's going to tell us how far we've gone. Alright, now our strategy here that we're going to use is we're going to use antiderivatives to connect these things together, as well as our initial conditions to determine the constants. So let's get started. Just a reminder, derivative of velocity, that's acceleration. So we can go backwards from acceleration to velocity using antidifferentiation. Now the acceleration, that is just equal to minus 10. Alright, and plugging that in and taking the antiderivative, we'd get the velocity. Well, what is the antiderivative of negative 10 going to be? It'll be a function so that if you differentiate it, you get negative 10. So it's easy to see that negative 10t plus a constant c is going to give us the desired velocity. Alright, so putting that together, that's our velocity function. So let's just write it out as our velocity function there. Negative 10t plus c. Alright, now moving on, we can use our next initial condition to determine what c is. V of 0, what was that equal to again? We'll go back and check. See that that wasn't 0, that was 30. Alright, and now we can plug these things in. 30 goes in place of v of t, 0 goes in place of t. So that gives us 30 equals 0 plus c, and so c is equal to 30. All right, so pretty good. We found out what that constant is, and we can summarize the velocity now. Take a second to do that. You're going to see that it will be negative 10t plus 30. Now this is really great news. We've got a big breakthrough here, because now we're going to be able to find TF. TF was the time to stop. V of TF was equal to 0. So just like before, if we plug things in, TF goes in place of T, 0 goes in place of V of T. That's going to give us 0 equals negative 10 TF plus 30. All right. And then solving there for TF, this is just basic algebra. Take the 30, subtract that on both sides, divide both sides by negative 10. Then we get that TF is going to be equal to 3 seconds. Okay, so pretty good. So that is a big goal. That was one of our pieces of information. Let's box that up. We'll use that later. All right. Now moving on, the derivative of position with respect to time, that is velocity. All right, we just found out what the velocity was. Go back and check on the previous page. Velocity was negative 10t plus 30. There we go. So we can take that, plug it in to find the antiderivative, negative 10t plus 30. And we need a function so that if we differentiate it, we get this. Alright, so you can check that if you take negative 10 divided by 2, t squared plus 30t plus any constant d, then that's going to have derivative this. Right? And so should be equal to the position function. Now, if you don't believe me, that's good. You should always be skeptical. Check it yourself by differentiating that we get the desired function. Okay, so moving on, we're going to use our initial condition again. P of 0, where were we at the start time? Well, in our frame of reference, we were at the origin, so P of 0 is equal to 0. And just like before, plugging things in, 0 for P of t, and then in this case, we're going to be plugging in the same thing for t. Okay, so that goes in for all occurrences of t. So we get 0 is equal to, well, that whole thing is going to be 0. So 0 there, plus, oh, big surprise, another 0 from that one over there. Those guys are both 0, plus d. So a little anticlimactic, we find that d is just going to be equal to 0. So summarizing so far, P of t, we'll just simplify a little bit. It's going to be minus 5t squared plus 30t. And that minus 5, that's just because negative 10 divided by 2 is going to be equal to minus 5. So I just wanted to simplify a little. Now plugging things in, we found that TF, the stopping time, was 3 seconds. Right? So we can take that and plug it in for our time. And then P of TF, so that's going to be negative 5 times 3 squared. Notice the squares there. Alright, plus 30 times 3. And then computing, that gives you 45 meters. Okay, so summarizing, Avi would stop at 45 meters away after 3 seconds. Alright, now just a second to reflect here on our solution. We found a positive distance, and that's what we'd expect with an initial positive velocity. Now if he had wanted to stop sooner, well, what would have needed to happen? He'd need a slower initial speed, or he would need a greater magnitude of deceleration, one of the two. Alright, so I've got some practice problems for you, and then there's also a solution as well, so work those out, and then there's also an extension for future work, as well as another full problem that has a full solution too. It's a slate variant. So good luck. Hope you have fun.